You've just launched your application. Suddenly, a massive, unexpected surge of thousands of users floods the system all at once. In seconds, the database locks up, the API chokes, the front end freezes. Every single feature collapses simultaneously, leaving your users staring at a blank error page. It is incredibly tempting to look at a crash like this and blame the servers. You assume the physical hardware simply wasn't powerful enough to handle the load, and the obvious fix is to buy more RAM or upgrade your CPU. But that total meltdown rarely has anything to do with a hardware limit. When an entire system goes down together, it is a flaw in the architecture itself. The hard truth is that unbreakable software does not exist. Every application has a breaking point. Relying on an illusion of perfection is dangerous. If you want your system to survive extreme stress, you have to design exactly how it is going to fail. We can see how this works by looking at this architectural diagram. Notice how the application is divided into layers. Instead of treating every feature equally, a resilient system establishes a strict hierarchy of needs, prioritizing software behavior over hardware strength. When traffic spikes and the system hits a bottleneck, like maximum database capacity, it has to make an immediate choice. It identifies the absolute most critical, non-negotiable functions and locks them down. Then it looks at the rest. These are the secondary features, the heavy, draining, nice-to-have processes that are useful but completely unnecessary for the system's basic survival. To protect that core bottleneck, the system intentionally severs its connections to those secondary features. It drops those heavy requests entirely, immediately freeing up massive amounts of database and CPU bandwidth. For the person sitting behind the screen, the application might suddenly feel a bit restricted, but crucially, the primary user flow remains completely unbroken. Let's apply this triage mechanism to something familiar, like a standard project management platform under a massive load. During that traffic spike, the system fiercely protects its core. You can still load your task list, you can still click the edit button, you can still save your work to the database. But in the background, non-essentials are instantly turned off. Your email notifications are delayed. Complex dashboard analytics are totally disabled. Search indexing gets paused. In software architecture, this controlled yielding under pressure has a formal name: graceful degradation. Because the system strategically sacrificed those background features instead of crashing, the vast majority of users trying to complete their work will never even realize the servers were milliseconds away from a total blackout. This strategy operates at a massive global scale every day. Think about a platform like Instagram serving millions of devices simultaneously. When their highly complex recommendation engine or an analytics pipeline inevitably hits a snag, the app doesn't crash. The main image feed just keeps loading perfectly. The failure is completely isolated to a single, non-vital module. But there is a major vulnerability when we use AI to build these systems. As this diagram shows, generative AI models naturally write code under a naive assumption. They assume all external dependencies and APIs will function perfectly 100% of the time. If one node fails without protection, it drags the entire network down with it. To build correctly with AI, you have to step in and act as the constraint. When prompting for system design, you must actively enforce fallback rules. You have to explicitly tell the AI to write circuit breakers and prioritize which features get disabled when an external service drops. The goal isn't to prevent a localized fault. Components will always fail. The objective is to stop that localized fault from turning into a cascading failure that takes down the entire database. True engineering is not about building an application that avoids breakage. It is about engineering the application so the inevitable breaks happen exactly where you choose.